you only had to wait 6 days, 23 hours, 30 minutes since last week, so it's like getting more brown bags in a week. We're excited to have Mark with us. Nick is currently an assistant professor at Madison, and he studied at NYU in sociology, at Master's also in sociology. And I first met Nick probably at PAA, where he had been sucked into formal demography by a NYU faculty member, Larry Wu. And I said, Nick, is there anything to introduce you about? He said, well, I wasn't really trained as a formal demography, but he was kind of sucked into it by Larry. And so he's continuing in this direction. I think the first paper was very formal. It was all about like period and cohort, and now you're getting into meaning in period and cohort, right?
Yes. Yeah,
so
melding the causality piece, some of my other work,
super
cohort stuff here. That's
super. So we're just really excited to have you here today, and we're going to give the rest of the time to you. So we go about 40-ish minutes. We may interrupt you. Is that okay?
Yeah.
Okay. And then we'll try to save some time at the end for questions.
Okay. Should I? Is this a stand-up?
You can do whatever you want, but typically people stand up. But you can prefer to say your name.
No. Is there a? No, I'll probably kind of wave my hands around the.
Yeah, we have some people on Zoom, but maybe not so many today because of our unusual time. Are there people on Zoom?
Yes. Do you want me to?
No, that's fine. But just so you know, so they're going to hear you. Yeah. But you can just worry about us.
Probably on that. Yeah. Okay. Great. So thanks, Josh. I really appreciate the really nice introduction. I'm still very much getting used to being introduced as like an actual person rather than a student. It's always nice. So as Josh mentioned, this is joint work with Larry Wu, or you didn't mention that, but okay. You did mention that Larry kind of is the one pushing me along in this direction, or was the one, and continued that way. So we're what I'm going to present today is kind of two separate projects, but the kind of piece that brings them together is the methodology that's being developed here. And it's very much a project in development. So one of these papers is at the R&R stage. There are some things that we're struggling with a little bit. And so if people do have feedback or questions that would help clarify things, that is super, super helpful. So kind of getting to these pieces, or looking at periods, looking at cohorts, how do we think about how these two mix together, and then applying a kind of causal framework to trying to understand those things. There you go. So joint work with Larry, also Jennifer Hill, who's at NYU, and then we've recently brought on a few grad students, Sung-Se Kwong, who is at UW, and Wenhao Jiang, who is at NYU, but going to Duke next year. So the first paper was motivated by trying to understand the effects of the Great Recession on fertility. Great Recession was the deepest economic shock since the 1930s. There were all kinds of hypotheses about how that would affect fertility. There was the research on this that happened kind of right after the Great Recession, all used period measures. And this works, right? You can measure effects of things on period fertility to some extent, but the causal effects here are actually pretty hard to identify. There's no, for something like the Great Recession, right? There's no untreated counterfactual group. We can't think of like, there was no group of Americans that was not affected by the Great Recession. So what a bunch of these papers had done is look at like places where unemployment changed more versus where it changed less. But then you're not actually thinking about the effects of the recession. You're thinking about the differential effects of unemployment on different groups or in different spaces. It's also another problem that they face was that there's non-stationarity in the ASFRs. So where you have ASFRs for all groups that they're estimating effects for are all going to be trending in different directions in different places over time. So it's kind of hard to pin down what exactly the effect measured in this period sense is getting at. And then third is always brought up with when we're talking about period effects or effects of period things on fertility, right? We don't know what the temporal effect could be. It's possible that if we see an effect on fertility, that might just be some fertility that's going to be recuperated later on in life. So The goal of this paper was first to kind of develop a methodology for trying to estimate the effects of period shocks on cohort outcomes, particular cohort fertility in this case, but as I'll talk about a bit, we can extrapolate the ideas here to thinking about other outcomes. And then we're going to do that for the Great Recession for estimate effects on cohorts that experienced it. And then if we have time, I have 42 slides here. We'll not get through all of them, but I'm going to talk a little bit about kind of extending this methodology to thinking about COVID. I once went to a PAA presentation where a grad student gave his job talk, which had like 63 slides, and he got all the way through it in 14 minutes. And it was extremely impressive. I don't remember a thing that he said, but I remember that happened. So usually what one does when trying to estimate causal effects of something is you think about what is the treated group, what is the counterfactual group, what's the difference between those two. This is me absolutely butchering all of the kind of theory that goes into thinking about causality, but kind of in general, that's what's going on. So what we're going to be trying to do the same thing. You may be thinking to yourself, that's ridiculous because there is no counterfactual. You are correct, and I'll talk about that a little bit. Then another goal of this is to attend to that non-stationarity of ASFRs. This too gets to be a little problematic, and there are some things that we're going to have to overcome here. We're also going to be able to observe cohorts over time, as we can when we track cohort outcomes. So in some cases, especially in the short term, we're going to be able to speak to some extent to tempo effects. These turn out to be more important in the COVID case than in the Great Recession case. So I hope I have time to get to that. So the key questions here are where does this counterfactual come from? Right? If we're measuring the difference between a treated group and a counterfactual, where is that? Because there is no counterfactual that's not treated. And then another question is, how do you estimate uncertainty here? Every cohort is only treated at a single age, so then you don't have kind of lots of treated units and lots of untreated units. So that makes estimating uncertainty somewhat more complicated than usual.
Is the Great Recession 1 year?
Great Recession was the first full month of the Great Recession was December.
But I mean, are you thinking of it as 1 year, or are you thinking of it as 7 years or 10 years?
It's a good question. We are thinking of it the way that the National Bureau for Economic Research defines it, which was January 2008 to June 2009. So 18 months is the Great Recession. One could theoretically think about when were unemployment rates higher than normal, and you could define it that way. We're just following the NBER and doing that definition. But you sound like one of our reviewers. I would love for more
innocent.
More on that. Yeah, don't reveal yourself. So I just to fix ideas, I'm going to use a simple annual example. So going back to this question, was it just 1 year? If we can fix ideas on an annual example, then it makes more sense to shift from there to the more complicated monthly rates. So since everyone in here kind of knows some demography stuff, when you think of period shock, right, that fixes kind of the age and cohort relationship of people who are affected by this. So every cohort is only affected at a given age. There's no cohort that is affected at one age and not at right. That's it. So if we assume that births in 2009 were conceived during the Great Recession, this is not a perfect assumption. This is to think about kind of what the concept that's going on. Then our treatment condition are births per woman observed for cohort C at age A. So that gives us the cohort specific age-specific fertility rate. And then our counterfactual is what would it have been had the Great Recession not have happened. This means, so I'm being very vague about that right now on purpose. This means that if we think about the period shock as being a discontinuity in time for these cohorts, that if we can identify effects, right, we're identifying effects for cohort C at age A along that Lexus diagonal of where they're affected. So we only can identify the effects for that cohort at that age. That is, we want to be very clear about that. We're not saying like this cohort would have been affected the same way had it happened when they were at a different age. So big question, very valid one. Where does the counterfactual come from? So if ASFRs were stationary, this is really easy, right? They would just use what ASFR, or if they were stationary in the case where the Great Recession was not happening, we would be able to assume that in the post-period, ASFRs were what they had been in the pre-period, and we'd be able to just estimate or calculate the difference. Because we know that they're not stationary, we're going to use trends in the ASFRs for older cohorts. So what had the ASFRs been for cohorts that were just above, or that had experienced that age just before the Great Recession occurred, and using trends in those. This is based on a projection method that was in a great paper by Mikko Mirskala, and I think Josh, you were on that paper too. Essentially, we're just projecting an OLS line forward through the 5 cohorts that are right before the cohort that is affected. This is really simple, which we think has a lot of advantages in that it makes it really easy to evaluate what's going on and what's going on under the hood of the model. It's also, I mean, this projection method in a lot of comparisons actually performs really well, especially in the short term. In the short term, these things are all going to be very similar, right? Short-term projections are going to be pretty good and going to be pretty similar no matter what method you use. As we get further out, then we're a little less confident, a lot less confident the further out we get, that the projection is doing a good job. But I want to preface all that by saying this is also problematic. So what we're trying to think of are ways to make this more robust to deviations from that assumption of linearity. So just fixing ideas, if we're thinking about the 1979 cohort was 30 when the Great Recession happened, our counterfactual is just estimated based on an OLS line for the 5 previous cohorts. So take these 5 previous cohorts, draw a line through it, there's our counterfactual. We can estimate or just calculate the difference between the ASFRs for that cohort at that age relative to what the counterfactual is. Extraordinarily simple, which makes this really easy to see when things are going wrong. There is, uncertainty, you can spread, there's only one cohort that's being affected here. We think we have a good way to fix that, and I'll talk about that in a sec. I think this linearity assumption, we need to be a lot more robust about it. And so I would appreciate some help if you have any ideas. So actually, I have it, that's later, okay. And I'll show kind of where my qualms come from specifically about that linearity. Okay, so if we fix ideas at that kind of higher level, just of the single year cohorts, now we're going to go down to more complicated using monthly data. These data are all publicly available. Use the US natality data for numerators, getting the number of births, age of mother to the nearest year, calendar month of birth. We're going to use data on race ethnicity. We can do this using the data from gestation too to try to get kind of conception cohorts, but we end up with the same results. So this is kind of easy to understand. We are simply estimating their cohort based on age minus year in which things happen, or other way around, age minus, or year minus their age. Very, very straightforward, very easy to replicate. And we're going to get denominators to calculate ASFRs from SEER. The NVR says these are the 18 months. We're just taking their definition as given. One could think about different ways of defining the Great Recession. We're just assuming this 9-month gestation period. We could relax this by using the gestation data. The results stay pretty much the same. So to estimate it for these 18 months, it's taking the same ideas. We have births to cohort C that were conceived during those 18 months. And then now we're estimating what that 18-month pattern of births would have been using the patterns in the 18 months of those previous cohorts. So we have to shift back a little bit. So we end up dropping one cohort in between. So we're not using the 5 previous cohorts, but rather cohorts 2 through 6 away. Because otherwise, if you extrapolate 18 months forward, you end up in part of the Great Recession. So we can't use that cohort. So instead of a single estimate, now we just have the sum of those estimates. And so we have these 18 monthly estimates, 18 monthly ASFRs for all the previous cohorts. We're going to use just one fixed effects for month 1 through 18 that fixes to the control for seasonality and stuff. And these monthly data are like quasi ASFRs, right? These are not exact, but we're doing the same thing for all the cohorts. So it should work out.
If you have fixed effects for all of the months of the Great Recession, how is there any effect of the Great Recession?
So the Great Recession was January through June. So in the 2 cohorts prior, we have January 2008 through June 2009. 2 cohorts prior, we would have fixed effects for January 2006 through June 2007. So it's just fixed effect 1 through 18, not for the actual month itself.
Okay.
So,
and first, apologies, I'm like the least demographer in this room, but I'm trying to understand where you're saying stationarity doesn't hold, but I think I'm trying to kind of understand stationarity for what, because clearly my sense from this slide is that you're using these patterns from previous cohorts, and you're assuming that those pattern-specific deviations are stationary.
So we're assuming that yes, but we're accounting for trends in those patterns. So we're saying there can be a linear trend in the monthly ASFRs, like a linear cohort trend. But if we assume stationarity, then we wouldn't need to draw a line through 5 previous cohorts. We could just use the previous one because we would be assuming that everything was the same across those 5 cohorts.
I see. Okay.
So we're saying like we're allowing for there to be a trend in those 5 cohorts. Otherwise, we wouldn't need to draw a trend line.
Okay, and then so the thing that's stationary are the residuals from that trend.
Yes, or the residuals from that trend should be, and we're going to use that instead.
Thank you.
You have another question, Josh?
No.
And this, I have to give full credit to Jennifer Hill. This is all her idea, and I love it. But so in this, we have these now, instead of 1 observation in the post-treatment period, now we have 18, but that's still not enough to kind of actually estimate uncertainty. But if our counterfactual is correct, then the average of the residuals across that whole line is going to be equal to 0. We're drawing an ONLS line. If the effect is 0, then the post-treatment period should also have residuals that equal out to 0. So what that means we can do is permute these residuals a bunch of times and look at what the actual estimate of the observed residuals look like relative to all of these permutations. And if they look the same as all of the other permutations, then that tells us that, or they look kind of just slightly different, then that tells us that our effect is not different than what it would have been if we had just kind of randomly picked some months. But if it's different, then we can draw some inferences based on that. So to do that, we can permute these a bunch of times, obtain 99% upper and lower estimates, and then we're doing this for 31 cohorts, so we're going to throw any correct for all that. So when we do that, this is what the results look like. They are kind of in line with what we would think, right? We have this left side is the percent change in fertility for each cohort, and the right side, panel B here, is the change in births per woman. So we have, in general, larger declines at younger ages, very small declines at older ages, but there's a lot of movement here. And so I was worried by this. And this it kind of bothered me, right? So then we think about like why does it make sense that this cohort the Great Recession would have positively affected them, whereas this one 2 years later would have had this very large negative effect, right? That seems strange. And I agree.
I mean, it's also that your uncertainty doesn't allow for them to be the same.
Right. Yeah.
Yeah, the uncertainty, I mean, the estimates seem fine to me, but the uncertainty seems way off.
Well, one or the other, or both. So this is where I think this linear assumption is fighting us, is that a lot of this is what's happening with this each individual cohort relative to the trend, right? That's where it has to be. So one of the things I like about this whole setup is that this is really clear, right? We can see this cohort the estimates for this cohort look weird. The estimates for these ones look different, right? And you can go in and say exactly what is happening that's making that occur. I think that's great. So if you took that cohort, this is the one where there was a positive effect. The window used to estimate, so we're using this 5-year window. The window used to estimate that effect is the results are really sensitive to what you do with that window. So here we're taking 8 cohorts instead of 5, and you would get a negative effect. Right? So this is, if we had gone in and be like, well, we're going to use 8 for this one and 6 for this one, and that, but you could basically engineer your results to look the way that you want to, not within some parameters, but you could do that, which is bad. You don't want that. But just be really clear. So if people have ideas about how to improve that step and how to make this both robust and kind of keep the clarity in there, I would really appreciate that. So one thing that we thought of that could be causing some of this variation is if there is a cohort effect, right? If an individual cohort is consistently different than the cohorts that came before it, then that cohort would show up, that would show up as an effect of the shock on our outcome, whereas in reality, that effect was already there on that cohort. We're not identifying the effect of the shock, we're just identifying the cohort effect. So we want to try to control for that or adjust for that. And we do that in 3 steps. So the first is we can estimate effects. What would effects on this cohort have been in non-recessionary months or in pre-treatment months, in months that are not affected by the recession? We call them placebo months. There should be no effect in that case. Take the median of those estimates in percentage terms, say that's the cohort effect, and just add that adjustment to our estimate. Okay. This is, again, I like this because you can see what's going on, and you can look at each of those 37 estimates. We picked 37 because we didn't want to overlap with the recession that occurred in 2003. So that's as many as we could go back before starting to hit another recession. But there's a big assumption here, right? We're saying there is this constant cohort effect that we can adjust for in percentage terms. And when we do that, the results are much smoother. So this black line here is that placebo adjusted effect, and the unadjusted one is the one in the red. So importantly, right, the placebo adjustment could kind of go different directions. It doesn't necessarily have to make things closer to 0. So if we take that and do the same procedure for estimating uncertainty, this looks a lot more believable to me than the other one did. Again, that's not always the way that you want to evaluate your results. So I want to keep improving this. But that looks much more plausible to me as a set of estimates of effects. It's much smoother and we wouldn't expect effects to vary so much between cohorts.
Just trying to understand what this figure is showing.
Yeah.
This is showing the effect on completed cohort fertility?
No, this is showing the effect on cohort fertility across those 18 months. So
on period fertility in some sense.
I mean, depends how you define period.
The age-specific rates are all within that period.
Yes, so it's the sum of the age.
It's showing that younger people have a larger percentage change in the left hand,
Yeah.
And older people have a smaller percentage change.
Right,
And then,
cohorts.
and then the absolute during that time.
Right. Yeah, cohorts who were younger when the Great Recession hit.
Yeah.
Yes. So you could take that and put it in a period, or you could think about this and kind of extrapolate it further beyond the 18 months if you wanted. You can do this for white and black women separately, and things get somewhat noisier, but kind of the same set of ideas is still there. It's still larger effects for younger people than for older ones. As things get noisier, then the confidence intervals get bigger, as they should. So, I mean, what are we at time-wise?
We're about halfway through, exactly.
Great, perfect. Okay, so the direct impact of the Great Recession on cohorts, like during the Great Recession, was rather small. Right? This is the lines here are about max negative 0.03 births per woman. That's not huge. It's not nothing, but it's not huge. And that is sizable in percentage terms. So as a percent of age-specific fertility rates in those 18 months, right, that is a rather large decline, but it's not massive. The largest impacts here were among younger women, women who were in their 20s when the recession hit, and larger among Black women than among white women. We're identifying these effects in a pretty short time frame. So it is plausible that effects would continue past the duration of the Great Recession, and we could, in all theory, kind of expand this method further along. The further away we go, the less certain we are that our counterfactual is working the way that it should. So we can do that. I don't do that right here. But it's also plausible that some of the births that are happening or that didn't happen during the Great Recession, then were simply delayed and do happen later. We can go ahead and project cohort fertility out to the future. Kind of what would we expect fertility to have been for these cohorts? What do we see? How did we estimate? What was our estimate for the effect for them? I always love to point to 1989, which is my cohort, and we had one of the largest effects, and fertility is expected to still be around 2. So this is these are the cohorts who were most affected by the Great Recession, according to our estimates, and yet they're still very much around 2. So it's pointing to the Great Recession as not being directly, at least in this sense, the cause of big declines in fertility. So yeah, that's the same one there. So I do not have to use my fancy skip to the end button.
Even if your outcome was instead like the timing, the ages, then you might say it's more consequential.
Yes. Yeah. I guess so. Yeah. So you could look at it from different angles and say, right, a 20% decline in fertility at that age is like that's pretty big. Yeah.
Do you want to take a couple minutes of questions about this first
I would love
paper?
to. Yeah. Yeah.
This is just a general question. Counterfactual, because the Great Recession didn't happen, which means the economic growth of the previous years continued, or what if you make the assumption that normal recession?
That's a great question. And so I've thought about taking this and doing it at the state level, and that would kind of cut the difference between what this is and what some of the other kind of comparing fertility in places that had higher versus lower changes in unemployment. Right, we could take state level estimates for unemployment and say these are states that the Great Recession had much less of an effect on, and these are states where it had a much larger effect. And we could get multiple lines there. And I've been thinking of doing that and have a good time too. But
Part is, what's the literature on the relationship between recessions in general and fertility?
yeah. So we do we know there's not as much on cohort fertility as on period fertility, because we haven't had the data to be able to estimate long cohorts and recessions. There's a great paper by Janet Curry and Hannah Schwant that does has cohort, but they only have 9 cohorts of completed fertility. But they do that where they're saying, right there, we know that there's a decline, and we know that that decline is larger when recessions are deeper. But what we don't necessarily, we don't know, one, we don't know the effects of the Great Recession, which is different than the recessions in the 70s, 80s. And so we don't necessarily know what any given recession, those effects are going to be. And I think that actually has come up a lot, which in the COVID ones, it's just a plug for the next 10 minutes of my slides, but it's been very different in the COVID recession. Liza, Josh.
Thank you. To go back to slides, I'm a little confused by the,
This one? That one?
no, the age, yes. I'm a little bit confused by the idea that, so could people who would have been teenagers in the Great Recession, and like some of what we've sort of seen in change in fertility, right, has mainly been a decline in teenage birth and like some of the stories delay. Why would we expect that the Great Recession would have the greatest impact on teenage birth outcomes instead of on outcomes for people in their 20s, especially given that it was like a subprime mortgage crisis?
Yeah, I mean, I think that's one of the things that is surprising.
Yeah.
And so the effects are not largest in absolute terms for that group, right? So the people that they're largest for are people who would have just been entering the job market, who would now or would have just been starting families, right? That kind of makes sense. In percentage terms, right? This is, I'm not entirely sure why teens would be affected more. I mean, this is you could think the selection into a teen birth. Who is it that's going to do that? Are these people who would have entered the job market directly after high school or during high school? Are these people that are then choosing not to have the kid when they would have otherwise because their economic prospects look better than they would have? I don't know, and I think that's that's a really good question, and that isn't a piece where I want to understand. Going back to this, like what do other recessions look like? Is that this? Can we look at the same patterns for other recessions, and do they look the same as this? I think that's a great question.
Yeah. So I guess I'm just stuck on what is cohort about this. The projection method is holding age constant, so it's a period projection method. The counterfactual, that is, the Briscoe method. The impact is during a single period. Is the only thing cohort about this is that you're using the word cohort? Or is there something where you're taking the past experience, cohort-specific experience, and somehow using that? Is the cohort perspective on the interpretation of the results, or is it in the model itself?
It's in the model. It's both.
Okay.
So if you think about the Mearskell method, Mearskell and Josh method, right? We're extrapolating that at each individual period, right? So you have in month 1 of the recession, there is age-specific fertility rates for month 1. The cohorts that are being used, or the timing of the fertility that's being used for month 2 is different than for month 1. So already, right, that is not a period. Each of those is a period, but this is the identity, right? By adding those up, we're getting the cohort piece. So that's different than if I had just estimated period effects. So for example, I could have estimated effects for 17-year-olds. I would get an estimate for 17-year-olds in month 1, 17-year-olds in month 2, 17-year-olds in month 3, or 17 in 1 month, 2 months, right? With that, or that would be 17 different groups of people. This I'm doing for the same group of people across 17 or 18 months, and I'm adding those up. So that is cohort. I think I think your part of the critique is that 18 months is not long enough to observe cohort outcomes, and I think that's very valid. And I think that there's something to be said for extending this further. Uncertainty gets bigger in that case.
Thank you.
Anybody else? Yeah.
Yeah, I had 2 quick things, and then maybe we're short on time, so feel free to be judicious about what you engage with. But one of them was inspired about this sort of, Yeah, to talk about literature on recessions and fertility. We actually wrote a paper in Jenna's class by Buckle that talked about how declines in fertility are actually a pretty reliable predictor of recessions. So we can think about explaining the Great Recession forwards, the effects of something called afterwards, but also beforehand, if there's something in the air that is preempting the recession that is also affecting fertility, if that's something to thought about. Yeah, the second thing is thinking about visualizing this data. You have a period, things going on, you have cohort, you have age. This makes me think of a Lexis diagram. Specifically, if you thought about a Lexis surface, then maybe you show something about births, maybe something like the difference between the observed births and the detected births on the Lexis surface, and then something.
Yeah, that I'll go back in time. That's a great idea. As I actually don't know how to model Lexis surfaces, and this is like part of my lack of training as a formal demographer, and so maybe you could teach me how to do it. But I think that's absolutely right, and I think that's somewhere where that would help answer the question about like, what is cohort here versus what is period, if we can do that correctly. But how to draw that out is something that I'm not clear on, but I agree. The Buckles paper, I love that paper as like it's like fertility as a leading indicator of recessions, I think it's called. And that is very valid. I think we get around that here because we're shifting to a cohort, or we're not including that kind of middle cohort. So the effects that she finds are actually pretty close to the recession. It's not like years in advance, it's like a few months. And so that's not happening here, but one could look at that specifically if one wanted. Great, so I have a few minutes. So we've been extending this work to try to think about using the same model and even simplified versions to think about the effects of COVID on fertility. So we're using data here from Human Fertility Collection, associated with the HFD. There are some considerations here, right? This is not perfect. The duration of the pandemic is not clear. We're going to do this internationally, so that's especially not clear with respect to different countries. And data availability is going to vary across countries. And we can think about things being like in the immediate COVID era, the 2021, and the longer term COVID era, 2022, 2023. We don't go up to 2023 yet, but thinking about what happened to trends in fertility. This is the example graph from Finland, which I think this is a much better linearity. I used the other one because it was bad to highlight that, but I think Finland is actually like, this looks like it works pretty well here. And there, I'm going to skip this just to get to some of the results because I think they're pretty interesting. So this is for the US. As the blue line here is 1 year estimates. So that's just looking at 2021 births relative to the trend from 2014 through 2019. So we're dropping 2020 because they're contaminated. Some of those were COVID births, so births conceived during COVID, and some were not. But we're only using that previous 5 years and the treatment year. So that's if you looked at 2021, and the red is if you looked at 2022. So here in the US, you saw an increase relative to what we would have expected in births to cohorts that were 25 through 31 when COVID happened. And then if you look 2 years out, that increase actually gets larger. So that is the baby bump in the US that we saw. There's also a pretty small effect here at later for cohorts that were older, but that's relatively large in percentage terms for those older cohorts.
So didn't fertility go down with COVID and then go up?
So it went down.
The net effect of the two?
Yes. So it went down in 2021, or in 2020 and early 2021, and then bumped back up. And this is relative to what we would have expected too. So COVID, it's not necessarily looking at declines versus increases, but declines relative to what we would have expected, or increases relative to trends.
But the interpretation of the slide is that COVID increased cohort fertility.
Correct. Yeah. It did that too for other countries like Korea, which we're pretty surprised about. The 2024 TFR came out for Korea, and it was had increased for the first time in a long time. And we had calculated these right around the same time that was happening. We were surprised, and then TFR came out. And so this looks like we could see the change in fertility happening. This is using births in 2021, 2022, differences from trends for these cohorts. And you could see that happening in these data prior to the increase in TFR that we observed in 2024. France looked super different. France is kind of an outlier in all of our data, but also very clear. And so I thought this was interesting, and then I want to put together a proposal to use the data at ENED to look at this at different regions for different groups, because I think this is fascinating. But declines for younger and increases for older. This looks like it all happened in 2021. So 2022, there's no difference between the 2022 and the 2021 line. So this was a change in fertility in 2021 that then reverted back to trend in 2022. Yeah.
Does this use your placebo correction approach?
Yes.
Can you remind us what placebos you're using for this then?
This one, so this would be years. So it's because we're using annual data here. It's the years going back from then. So from 2019 back to 2011, I think, because we wanted to cut before the recession. So it's not as robust a placebo adjustment as the other one, but it's there. Portugal also looked really different. You had declines in 2021 that were smaller for these cohorts here, but then fertility recovered a little bit in 2022 relative to what had happened in 2021. So very different trends across countries. In the US, we had the cohorts that were happening. So there's some evidence of recuperation in Portugal, but not in places like France. So in conclusion, I think you can think about this method as working to the extent that you believe the results to identify short-term cohort effects of period shocks under minimal and testable and kind of visually testable assumptions, which I think is great. I like when you can see what's going on under the hood. And I think it also provides very clear and interpretable results that we can see exactly where the results are coming from. We can interpret that as what's happening relative to what we would have expected to happen. I think it's useful for lots of applications. We're using this to look at the effects of COVID on cohort mortality with Michelle Guillot. You can think of Wen Hao has taken this in a totally different direction and thought about kind of politically what happens when events happen with cohorts. Can we think about the trajectories of their ideology based on when they were affected by the event? Wen Hao is also writing up an R package, so if you're interested in using this, that will be available soon. I also want to say thank you, but if you're interested in any of these other countries, we have a lot of them here. But thanks.
Thank you so much. We have lots of time for discussion. If people could just raise their hand before I start calling you. Question. Was inspired by the first question? Aisha.
Okay. Okay, let me see if I can say this without confusing myself more. So you, so inspired by Josh's question. So you are not, so you're 17-month-old, month one, you're following then follow that cohort. But what have you done is the cohort effects to estimate an age-specific effect. So you look at 17-month-olds and 70-year-olds in month one, 70-year-olds in month two, 70-year-olds. And you could do the same,
Yeah.
Same. I guess how would that look compared to what you see in the cohort?
So I think that is so there are two ways to answer it. One, like that's kind of the typical way of doing it, and that's much easier. And not to knock that. But I think it's less interpretable, right? So then I'd have a whole bunch of coefficients. And to actually, like, how do I think about the effect on 17-year-olds 9 months in, right? They were affected when they were 16 in 1 month, 16 in 2 months, 16, right? So they're affected at different ages. And the further out we go, the kind of more wishy-washy that gets. And to use a technical term. And so it makes, to my mind, it makes much more sense to think about a cohort which is affected all at one age and then trace that cohort over time than it does to think about ages and think about cohorts that were affected at earlier ages and then now they're this age, earlier age, and now they're this age. And so that's a whole bunch of different people who have had different sets of experiences up till then. I mean, cohorts are also made up of that, but it makes more sense to me to think of a cohort as the treatment is fixing the age period cohort relationship right there and trace that over time than it does to kind of mishmash cohorts that were treated at different ages. Is that clarifying or worse?
Given that you're imposing smoothness, would the results actually look different if you did Aisha's analysis?
And I feel like it could tell you something interesting if it did,
Yeah.
right? About the cohort. It could tell you something about the cohort.
Yeah. No, that's a good question. And that, so like, no, this doesn't do that. I was thinking that might be useful. No, it doesn't. That's a good idea. I think, yeah, and I think if anything, it would be helpful to illustrate what's going on. And so I will do that. Thank you.
So I'm going to jump on Aisha's comment and and maybe it's because we do surfaces, but I think that rather than prioritizing one direction, thinking about cohort or age, thinking about a surface, and then you impose some sort of smoothness constraint on how a shock works through, then you can compare that with your prioritization, and you can see whether or not a smoothness constraint on a surface looks, if it stands out. And if it stands out the same way for certain directions on the surface.
Yeah.
And I think that and some of the things I've looked at, modeling the surface looks like it's hard, but if you add some sort of smoothness constraint, then it actually simplifies things quite a bit.
Okay.
So I'm going to recommend that. And I think it would sort of address some of these questions that you've been hearing here about.
Yeah.
How does this cohort? Yeah.
Yeah, no, I see that. And I think that's a great idea. I think, or what this conversation has taught me is that in some way, and I think the surface would be helpful for doing this, but in some way, showing where the differentiation occurs and when it does, I think would be helpful. So if I can kind of go back to this, I think you're in the very short term, in the first few months, they would look almost identical. As you get further out, then they're going to look pretty different. Right? You wouldn't be able to see this in just the age-specific trends. You would, because this code, if you wanted to see it right, you would have this one and this one would be two separate points. And you wouldn't be able to see that this cohort had actually recuperated unless you wanted to add up the ages. You would have to do that math in your head in order to get that result. And I think that's important, but I think you're right that kind of bringing that out is going to be useful for making this useful to people.
Sorry, this is an aside. Could you tell us again, what is the 2-year line and what is the 1-year line here?
So this is if we looked at trends 2015 through 2019, and extrapolated and then said, what's the difference between 2021 observed versus 2021 predicted? The red is if we use that same line but extrapolated to 2022 and said, what would we expect 2022? And so this shows, right, there was a big decline in 2021 relative to what we would have expected, and then they recuperated some births in
So it's
the next year.
2 years afterwards, not 2 years together or something.
Well, it's kind of the same, yeah. I mean, it's like if we added those together.
Oh, because of this cohort thing.
Right,
Because
exactly.
Okay, I see.
Right, and if
Okay,
it wasn't, then those lines would be kind of on top of each other. You'd have to do that math, but this would be.
I see.
Jen? Sorry, Josh.
Oh, go ahead.
No, Josh is just the person pointing.
Oh.
No, please.
One of the things that I think has come out of the cross-national COVID work is that none of the theory that we had about how a fertility response would respond to this kind of event has panned out. There is, there's nothing comprehensive that makes sense of really disparate results. And so I'm wondering if using this approach lends itself just to a more cohesive explanation. And you don't need to know that now, but
Yeah.
maybe you'll learn.
Yeah, I think that's a really good point. And one of the things that we're searching for is why did this happen in Portugal? And part of that, I mean, you can come up with any kind of just so story ex post, but then our goal would be to say, like, if we can find some pattern across countries that kind of can explain this. I think France is going, and using some kind of spatial analysis within countries will be helpful for thinking about, can we look at US states, places that did, what are policies that happened, what did the economy look like? France, we'd be able to get the spatial data on this too. Thinking of like lockdowns that were particularly intense in France, the recession that was particularly deep in Portugal because of effects on tourism that then recovered in 2022. So we can make those stories, but I think you're right, like synthesizing that into something bigger is going to be, I think we have to get a handle on that first.
Is it, I don't know what the data are like for this, but is it possible to look at, instead of fertility rates, like parity progression?
Yeah.
Because that might,
yeah,
I would, if there's postponement or whatever, I might see something interesting.
Yeah, no, that's good.
But we look at what?
Parity progression, like the rate at which we get.
Yeah. That is, so it's, one could do that for counts. I think for rates, so you could do that in France, which is part of the reason why I'm really interested in French data, not just because I want to hang out in Paris, but it's nothing. But they have parity specific population estimates, which we do not have. Like maybe at the national level, there's a
So
way
the
to do it.
HFD will have a lot of that for different countries.
Okay.
Yeah.
France, you can get them at like much more local levels. So thinking about which that is not possible to do here, but I'll look into it for other places to go.
Great, thank you so much, Nick.
So we're out.
Oh, let me just.
Stationary.
And are you excited?